going to look at prototype materials and a couple tools and just a few random things. So this is just an ensemble of some of my favorite materials, and you might like them as well. And I want to start with 8020, which is an extruded aluminum that's used to make a lot of frames and all kinds of and these are U channels in steel or stainless steel, typically, and they're cheap. And you see these holding up electrical conduit and piping. You'll see small sections of it doing that, often overhead, or we even have this in our workshop. They're holding electrical conduit on the wall, and there's clamps that attach to it, grab those inner grooves to clamp piping very easily. And then there's these insert nuts too. You can see spring-back insert nuts, so you can screw things to them. There's a whole bunch of hardware associated with it. And again, it's really commonly available. And you can get different depths, so you get different strengths of these U channels. It's not really meant as a structural piece, but it can be used that way. And you see it in the picture in the upper right, it is used that way. I have a student now for capstone. He's designing an off-road capable supply wagon and is making it out of this. I've worked with stainless steel for some custom designs, and stainless fasteners especially get a bit gummy and they're a bit hard to use, but you can get this in painted, galvanized, stainless, and it's quite inexpensive, so for what it is. You can cut it with a hacksaw or a chop saw. So that's U-channel. It's sort of the regional thing. We call it Unistrut in the Midwest. This is a perforated angle iron. You can buy this at a supply house of various sorts. This is galvanized steel. It's fairly cheap. You can cut it with a hacksaw. It's not so strong in torsion unless you make a U-channel, so it'll tend to twist. But you can make nice metal structures with this just using regular hardware. So it's convenient. There's holes all over the place, so you can kind of adjust things and work with it that way. And again, it's very commonly available, which is a nice plus to it. And if you do make it in the U shape or even the square shape, you can get a good torsional performance. But it's handy. And this is all in the context of prototyping when you don't exactly know what you want, but you know you want it to be strong. Great way to scale up things too. So if you're dealing with small prototypes, you can scale up and show people what it's like when you're closer to the operating load and size. And that's very important when you deal with linkages. This is showing a selection of some of my favorites, and you've used a lot of this. So 1x2 pine, which we have in the studio all over the place. Also basswood, MDF, and OSB we'll talk about. So first 1x2 pine, I like that for doing large structures. It's cheap, about $2 for 8-foot length. And you can get different qualities. So it can be a little more than that if you get nice straight ones. But that's about the price range. I told my children when they were young that they could buy them as much as they wanted, and to make things. So you can make airplanes, you can make buildings, you can make pterodactyls, you can make whatever you want out of these. And it's cheap and fast. You couple it with a brad nailer like I have on the upper right. It shoots in brads with compressed air, and you get something that's very joyous to do. Some of you have built bridges in our studio, and you know what I mean. Once you get everything cut up, it goes together very quickly. And if you couple it with glue, it's very strong. Those brad nailers aren't strong. They do things very fast. And then balsa wood, you're probably familiar with, is soft wood that you can cut with an X-Acto knife. So that's probably its biggest advantage. You can cut it with an X-Acto knife. Really easy to work into sand. It's light and good for model airplanes and all sorts of things. And then basswood is unique in that the grain structure isn't problematic, and it's easy to carve. It's strong. You can buy different shapes in basswood, and it's very versatile as far as that goes. Then there's medium density fiberboard, MDF. There's also a lighter weight version. This is what countertops are made out of, and it's what we're looking at in the lower right down here. And it's sort of plywood, but more flexible than plywood. You can do more with it because you don't really have any interlaminar issues to contend with, and you can do all sorts of neat things with it. So a real good go-to object, especially if you're doing any routing or such with when you're trying to get complex shapes into it. And then finally on this screen, you have OSB, which is cheap, the cheapest paneling you can buy, basically. So it's kind of like scrap wood and glue mixed together. It's less expensive than pretty much any other board, I would say, for its strength. So the biggest bang for the buck, I would say, for if you need big panels that are reasonably strong. Good stuff. Houses are made out of it, except the corners and the decking and such. But good material and reasonable price. So again, maybe I made a boat out of this using just OSB, and you cover it with fiberglass and epoxy and do all kinds of cool stuff with it. So it's a great way to make big structures that you can actually sit on and do things with. So it's a lot of fun that way. And then foam is sort of the cousin of the OSB, I'll say, in being cheap and light. And first is wren shape, which is really actually very expensive. It's a polyurethane, and it's kind of like MDF, but it's much denser, and it's used for preparing for molding, like vacuum forming and things like that. So it's a really good material. I have some in the studio. It's expensive, it's heavy, but you can get a lot of detail in it, and it's dimensionally stable. So it's a really good material for doing molding and those kind of processes. Then polystyrene and polyurethane foams, big bang for the buck. So if you want to do something that's volumetrically large, like the Halo gun I have in the studio or something, foam is really good for that. And you can carve it. It's messy. The polystyrene especially so, but it's you know about that. I think just how messy it can be. You cover it with spackle, maybe Bondo even, and you can get a rigid coat. If you heard the discussion we had from Sight and Sound, they talked about the hard coat they put on top of foam. So it's very common to work with foam and then coat it with something that protects it. But foam is big, nice, easy, and light to work with. So it's good stuff that way. And then finally, I have foam board or foam core, which I call it normally, which is paper-backed foam. So it's paper on both sides. And you can get the foam in different colors. So if you look at the lower right here, we have black and white foam core. And with the paper, it opens up some possibilities. So one is you can spray paint it, because unless you get foam safe spray paints, they will dissolve the foam. And maybe some of you experienced that. So it dissolves the foam, and that's no fun. With paper backing, you can paint directly on it. But you can also make hinges and do all sorts of things. I use it for doing linkage checks. If you're trying to design a big linkage, it's basically fancy corrugated cardboard. You can do the same stuff with corrugated cardboard. With foam board, you get nice edges, which is good. And you can actually use some of the paper for hinges too. So you can cut part of the way through and leave the paper on one side. You have a hinge very easily. So I've got a video on that talks a little bit about foam core. It talks quite a bit, I guess, about it. And it's a good way to make big, light objects. The prices range from dollar store stuff at 99 cents to about $3.50. So there's quite a range of prices. You can get different thicknesses too. And then some tools. Now, I put the drill there at the left. One of the advantages in terms of prototyping drills is it's a cheap way to get a motor. So even if you don't want to drill anything, if you want a motor, that's one of the cheapest ways you get it. You just rip the motor out. I mean, they're available all over the place. We've used them to drive our carts with, kind of make custom cars and use 2 drills to run the cars. So it's cheap way to deal with that. And then I just had a couple fingers. This is perhaps a bit silly, but you've got a jigsaw or bandsaw. I guess in many ways, depends on what I'm doing. Bandsaw is my favorite. And then the belt sander. So I just have a portable jigsaw because we have one in the studio, and they're pretty versatile as far as that goes. And I've got a phone call coming in, as it turns out. And you can see this one has this oscillatory motion that you can drive into the material better. So you can cut a lot of things. You can change the blades to deal with metals and foam and all sorts of specialty needs. And then this sandpaper or the belt sander is especially helpful. I think maybe you've all used that because it's how you finish things up. The belt sander can also destroy things. So if you haven't had that happen, that could happen. But I use it all the time. And light touch, you can do all kinds of wonderful things with the belt sander. And then just some other prototyping items, right? Connects here. So connects are a good way to kind of study linkages. It's a bit clumsy with linkages, but you can experiment with gearing and motion and make big structures, and they're easy to work with. And they're clean, they snap in, they're Alcatel materials, so really quite strong. And okay, and then I just have a couple items here. This happens to be a planetary gearbox set. So gears usually intimidate people. So if you're looking at dynamic systems, things that move, that scares a lot of people. So one way to get over that is just not to think about it too much, we'll say, but to build it. So that's true with linkages and gears. You can kind of experiment with things and see how they behave. And this is just kind of visual of that. I have Technics here. I've never used this for prototyping, but I think it's very cool. So I just want to include that in here. And they have little pneumatic systems. That's what these black hoses are. They have this motor-driven piston compressor that reciprocates and makes a small amount of compressed air, and you can actuate things with it. So it's very cool. So when you look at transmitting power over distances, which is sort of why I have this image in here, you can do it with electricity. So you can send electricity through wires to motors. So, and there's high precision, like stepper motors and stuff that can do a lot of precise movement. And there's a problem with motors often is getting high torque. You can get high speed, and speed times torque equals horsepower. So you can't get decent horsepower, but to get high torque, like low end torque, is tough system on electric motors. So hydraulics generate really high torques, and so do pneumatics to some degree. So the advantage of pneumatics is you don't have to send the air back; you can just bend the air, and it's safer. So you're sending compressed air in one direction, like you see in this excavator, and then when you're done with the air, you vent it. With hydraulics, you have to send it back, as you do with electricity, so to speak. So anyway, that's one advantage of pneumatics. But then you have here, you see the belt drives and chain drives are great ways to transmit power to over some distances. So if you're going a long distance, you want electricity, hydraulics, or pneumatics. If it's a medium distance, you're talking about chains and belts. If it's closer, you're talking about shafts and gears. Just way to think about things as far as moving power from point A to point